Nandito ulit ako para turuan kayo mag-multiply ng rational expressions. So, pareho lang siya ng pag-multiply ng fractions. Halimbawa, thirds times 9, 4. Okay. Multiply na yung fractions. Nagawa natin una, pwede tayo mag-cancel, di ba? No? Pwede rin naman ng 2 and 4, common factor is 2, so we can divide each of them by 2, so this becomes 1. The common factor is 3. Divide them by 3. And then we have 1 over 1. The answer is just 3 over 2. Or, yung iba ang ginagawa, so they multiply direct, that is 18 over 12. And from there, look for a common factor that they can divide to both the numerator and denominator, 6. So, if this is actually some fast way. But if we do it the long way, the long method, it will be getting their prime factors. 2/3 times 9 over 4. You can make this as 2 times 3 times 3 over 9. And then 3 times 4. Okay, so we cancel the common factors. So we cancel this. It's pair of 3s. So only numbers left are 3 and 2. So these are different ways to multiply. Get our answers in simplified form. So this one is actually the things that we will be using in multiplying also rational expressions. Okay? That's right. Okay, so we need also to recall the laws of exponents because we're dealing also with variables and with exponents. So we have to follow some rules in in the exponents. For example, product rule, we add exponents of the same base. We have the quotient rule. This time we subtract exponents. We have also the power rule, where we multiply exponents. Okay. We also have the zero exponents. So if it's okay, so these are the things that we need to recall in terms of exponents. So if you have P over Q times R over S, that is just P times R over Q times S. Where Q and S both not equal to 0. Because if one of them is 0, then our expression will be undefined. Let's try this example. Example number 1, if we have 2 over G times 5 over 3G H. Okay, so what we can do here is we can multiply the numerator, that is 2 times 5, and then we multiply the denominators. You have the 3 times G times H. And then by simplifying, we have okay, so we see there is no common factor in the numerator and in the denominator that we can cancel out. So in that case, we can just multiply it. 10 over 3, because you have 2 G's here, so that's G squared H. This will be our product. Let's try one more example. Let's try example number 2. We have 4b over 3a cubed times 15ab squared over 2b. Okay, so we have different ways of solving this. One is we can directly multiply them. That is just 4b times 15ab squared. So that will just be from, we multiply first the coefficient. 4 times 15, that is 60. Then we have a, and then the b times b squared, we have a b cubed. In the denominator, we have 6 for 3 times 2, then a cubed and b. And then we can now simplify our expression. So 60 over 6 is just 10. And then a over a cubed is a squared. The denominator, okay, because that will give us a negative exponent. And then b cubed over b is b squared. Because that's a positive exponent, so we put that in the numerator. Here, our answer now is nb squared over a squared. Another way of doing this is we can cancel common factors vertically or diagonally. In this case, we can cancel the 4 and the 2 here because they have a common factor 2. So this becomes 1, this becomes 2. And the b here can be canceled out. So no more b. And then 1a here and then 1a from the a cubed. So it will be minus 1 a squared. We can also simplify the 15 and the 3 by dividing both of them by 3. So you have 1 and 5. Okay, and then we can now simplify the numerator. We have the 2 times 5 times b squared, that is 10b squared. Over, we have a squared, and then the 1s. Okay, so that is just a squared. So we'll get the same answer. Okay, so now it's your turn to multiply the following expressions. I'll give you time to solve this, or you can pause this video, then you can answer. After a while, I will show you the answer. Okay?
Many months later.
Okay, we're back. So let's try to answer the following items. For number 1, 1/2 times 5 over 9. So because there's no common factor when we check diagonally and vertically, so we just multiply 1 times 5, which is 5, and 2 times 9, we have 8. Okay, next, for number 2, we can cancel here vertically the u and the u squared. So this becomes u raised to 1. And then this u will be cancelled out. It just becomes 1. And then for v, we can cancel the v here. So no more v. But here you see you can cancel again the u denominator here, the u in the numerator of the second fraction. What's left now is just v squared. For number 3, we can cancel the b here, squared, and another b here. Okay, the a can be cancelled here, so this becomes 1. Okay, aside from that, no more terms to cancel, so we can just multiply 3b times 2a. So that is just 6ab. Okay, and for the last one, here we can cancel out the 12 and the 14. They're both divisible by 2, so we have a 6 and a 7 here. Between 7 and 49, this 7 becomes 1 and this 1 becomes 7 by dividing each by 7. That's a common factor. And then for p here, and then the p squared becomes just p raised to 1. Okay, we have the r cubed becomes 2 because we will remove 1 r from the numerator. And then that's it. So we multiply. Oh wait, there can be something to cancel here pa. We can cancel the 7 and the 7 here. The 14 a while ago. Okay, so that is just 6. We have 2 q's here, so that's q squared. Over, okay, no more coefficient here, so it's just 1. Then r squared p. Okay, so those are our answer. I hope you got all of them correct. But of course, But of course, we all know that multiplying expressions is not just only for one term or numerator or denominator. It can sometimes be two or more terms in a numerator or in a denominator. Like this example. Let's have m plus 1 over m times 6m over 3m plus 3. In this example, it's very tempting to cancel the m here because they're both m. So you might think that you can cancel that. But that is not allowed. You cannot cancel the m for this fraction because m is not a factor here of 1. M plus 1 is one expression. It's a binomial. Okay? And m. Imagine if we have a 3 plus 2 over 3. It's not possible also for us to cancel the 3 here. Okay? But if it's like 3 times 2 over 3, then we can cancel that because 3 and 2, these are factors. Or some says it's because it's multiplication, then we can cancel. But if it's addition or subtraction, we cannot cancel terms. We cancel the whole expression. So if you want to cancel the m plus 1, you should have also an m plus 1 so we can cancel the whole expression, not just m, not just 1. Okay? Okay, so how do we solve or answer this problem? So first, we need to make sure that everything is factored, especially the ones with more than one term. Okay, so m plus 1 is already factored. M factored 6m, that can be factored as 2 times 3 times m, so that's okay, we can leave it like that. But 3m plus 3 here can be factored. So this one, when we factor the 3m plus 3, we need to check on first their highest common factor. Okay, so their common factor is 3. So we need to factor out first 3, and then we divide each term by the common factor 3. So that will be our next factor. So that means it's 3m divided by 3, you get an m, plus 3 divided by 3 is 1. To check, we can multiply 3 again and distribute that to m and 1. And then we will still get expression 3m plus 3. So we can write this as 3 times m plus 1 instead. Then we can try to check now if there are things that we can cancel. So here we can cancel the m plus 1 now and the m plus 1 here. Here we can cancel the m plus 1, because 3 is multiplication with this expression m plus 1. Okay? And we cancel the whole expression m plus 1 and m plus 1, not just m or not just 1. Whole expression, the whole binomial here. Aside from that, we can also cancel the m here. Okay, so no more m for us here. And then another number here that we can cancel, the 3 and the 6 becomes 2. This becomes 1. When we simplify that, it's just 2 over 1 or just equal to 2. Okay, another example that we can also answer and practice on, we have m minus 1 over 2m plus 4 times 3m plus 6 over 4m. Again, we need to make sure that everything is factored properly. So we can factor the 2m plus 2. Common factor is 2. Then we divide each by 2. We get m plus 2. For 3m plus 6, the common factor here is 3. So we can make this as m plus 2. Dividing 3m and 6 by 3, we get m plus 2. For m minus 1, we can't cancel that anymore. They don't have common factor, so that's still for m minus 1. And then we can now cancel. Let's see if there are things that we can cancel out here. We can cancel the whole m plus 1 here and m plus 2, sorry, and then m plus 2 here. And then that's it. No more. So we have an m minus 1 and 3 here. So that is 3 times m minus 1. Here we have a 2 and 4m minus 1. Okay, you'll see that there's no other terms or factors that we can cancel out. So we can now simplify our answers as 3m minus 3 by distributive property, 8m minus 2. You think, can we cancel here? M? Is it possible for us to cancel m? Because they're both m. Okay, no, that's not possible. As we mentioned a while ago, because this is subtraction, we cannot cancel that per term. We need to cancel that as a whole expression. Unless it's multiplication. The operation is multiplication. Multiplication. Okay, so that is our answer. Okay, let's try the next one. So we have here x squared plus 5x plus 4 over x squared minus 1 times x squared plus 2x minus 3 over 2x plus 8. So you see here now we have a trinomial in the numerator. So we need to factor that using quadratic. Okay, so we can factor this. So we can rewrite that here. So x squared plus 5x plus 4 can be factored as x plus 4, x plus 1. So you can use here the window method or easy method or trial and error for you to get the factors of x squared plus 5x plus 4 over x squared minus 1 is difference of two squares. So how do we factor difference of two squares? It will be just x plus 1 times x minus 1 times x squared plus 2x minus 3 can be factored as x plus 2 and x minus, x plus 3 and x minus 1 over 2x plus 8. This one is, we can factor this using common factor. We factor out 2, then that x plus 4. Then we can now cancel factors. X plus 4 and x plus 4 can be cancelled out here. X plus 1 and x plus 1 also. X minus 1 here. Okay? Left with x plus 3 as our numerator and 2 as our denominator. This is now our final answer. Okay, so that's the end of our lesson for multiplying rational expressions, but I will leave you with 3 items for you to answer. And we will discuss this when we go to division of rational expressions on my next video. So don't forget to subscribe, like, and comment if you like this video. Okay? Bye. Thank you.